Hello, everybody, and welcome to our monthly mechanical engineering virtual meetup. And today's topic is very interesting, kind of the follow-up topic, and it's on data reuse, 2D plus 3D design data. My name is Anton Fedoseyev, and I'm content strategist in customer success organization. And today we have two awesome guest speakers, Paul Munford. Paul. And John Vaughan. We'll go through quick introductions a little bit later, but let's start from talking about some quick housekeeping rules. So first of all, Paul, if you can click through.
Sure.
Can you go to the next slide, Paul? Yeah. Excellent. So the lines are muted to reduce the background noise because we're recording the webinar and you will receive recording very soon. The lines are muted, but you are more than welcome to ask questions at any point of time. Just use a Q&A window or in the end of the session, in fact, we'll be able to unmute the lines and we can have a conversation and you will receive the recording very soon. So mechanical engineering meetups is basically a regular cadence of events. It happens every second Thursday of each month. And you can register to the next 3 sessions. We usually try to announce the topics in advance. The goal of the session is just stay in touch and talk about the solutions that you already have access to, share best practices, and build the community so we can talk to each other live and also watch the recording and kind of keep this more conversational format. Mechanical engineering meetup is not the only meetup that we have. In fact, we have quite a few of them for most main professions that our customers keep. But today's topic, let's jump into it. But before we do it, maybe we'll go through a quick round of introductions. So Paul, do you mind talking about yourself a little bit?
Sure. So my name is Paul Munford. I'm a technical marketing manager for the product design and manufacturing collection. So that just means that I work with the marketing team to create the content they need to make Inventor look good. Some of the stuff we do, the main stage presentations for AU, and we produce a lot of the kind of what's new content, all that kind of thing. And this particular topic, I'm particularly interested in this topic because I was an AutoCAD user myself. I spent about 10 years drafting with AutoCAD before I even learned Inventor. And so I had to move a lot of my legacy stuff from AutoCAD into Inventor. And in fact, while I was learning Inventor, I would quite often start in AutoCAD because I was familiar with it, and then just take maybe one tiny part of my model, design that in Inventor. And then as I learned more and more, I was able to shift more and more of my design process into Inventor until probably about 5 years, I was almost fully Inventor orientated. So this is something that I've been through and enjoyed using both, and found some of the pain points, and I'm kind of quite keen to share this with everybody today.
Yeah, excellent. Thanks, Paul. John?
So hi, everyone. My name's John Vaughan, and I'm a designated support specialist working for Autodesk. So I've been with Autodesk for the last year and a half, and I work with some of Autodesk's larger customers providing technical support. So my main focus is on Inventor and AutoCAD Mechanical. Before joining Autodesk, I was working as a mechanical engineer for a large oil and gas company designing drilling equipment. And similar to Paul, I'm quite interested in this topic. The company that I was working for most recently was just kind of working through this transformation as well. So unlike Paul, I was kind of more used to Inventor, but we had historic AutoCAD data that we were trying to get the best use of and still move forward with our designs. So yeah, happy to be here and excited to present today.
Excellent. And why don't we start from just polling the audience, and we'll start from asking a quick question. What kind of environment do you use most of the time? Just click on the screen to pick the option that describes the best the type of workflows that you use. Okay, let's keep it open for 5 more seconds, and we'll share the results with everybody. Okay, Okay, so excellent. Let me close the poll and share the results. And we have even split between the bottom three options, 2D and 3D, mostly 3D and some backwards workflow. But I hope most of the things will be useful because we're talking about data reuse, right? We're not talking about 2D design today, but 2D design was the topic of our previous meetup, and we talked about productive ways to do it. But as a follow-up discussion, Paul, what's your opinion? Is there still a place for 2D design, or it's kind of gone?
No, I think absolutely. A lot of people still find 2D more accessible than 3D, and I think a lot of us still think in 2D, so we tend to want to start by doing sketches before we actually start working in 3D. Plus also, when we talk about 2 dimensions as a documentation, a lot of us still have a legacy requirement, or let's say a contractual requirement, to produce a 2D drawing at some point. So although internally we might start to use more and more 3D data for downstream, at some point when we go out to have something manufactured perhaps, or when we're dealing with our customers, they're expecting us to produce a drawing. So drawings are still part of the workflow, and we like drawings, right? So we like a piece of paper and we like to print it off, and we like to have a review session with our red tip pens and kind of mark it all up. But it's very reassuring to get your highlighter out and color in the markups that you've done, right? So we like all that stuff. It's still something we're very familiar with. So although the technology is moving onward, and there's lots of opportunities for us to start using perhaps 3D annotation, or start using things like Vault on the shop floor to be able to send drawings directly to the shop floor without, or send designs directly to the shop floor without having to send a sheet of paper. I think we're still something we're very comfortable and very familiar with.
Excellent. And John, what about you? You started your design journey straight in Inventor, but what do you think about 2D design?
Yeah, it's true. So most of my work has always been in Inventor, but really for the deliverable, we're still working with a 2D drawing. So I've been working with engineering managers in the past where, I want some guidance on something, but they wouldn't talk to me until we have all of the 2D drawings out printed. And like you said, start to go through them with the red pen. And that was the way that it was visualized. So in my opinion, I think in some cases, the 3D models are great for just providing the most clarity, but there's still everybody's familiar with the 2D drawings. They've been conceptualizing designs this way for years, and it's just what's most familiar to people. Yeah,
I think it kind of makes sense. So we just choose the most effective and productive environment for the task, right? So we don't have to be sticking to just certain, let's call it like religion in this case, because I mean it's important to just use the most effective tool.
And that's quite right. In terms of drawing efficiency, back in the day, my bosses always used to tell me, if you can write a note, don't bother drawing it, right? So you should use the thing that's most efficient. Sometimes if you're doing a layout of a big site, it doesn't make sense to do that layout in 3D. That can be a 2D drawing. It's when you get into the mechanical details that it can be quite hard to conceptualize everything in 2D, and perhaps that's when you want to switch over and start using 3D workflows. So it's great to have a variety of tools available to you, and you can make choices about which tool is most efficient for this part of the process. Sometimes at the very beginning of a job, we might just do some typical details, like just the detailing in 2D, just to try and figure out some particularly finicky things we wanted to get resolved with the client before we went into full modeling, to save ourselves modeling the entire thing and then having the client tell us they didn't like it. So it's good to have a variety of tools available to you depending on what you're working on.
Yeah, and one thing you mentioned that, a lot of the times maybe it's our customers that are requiring the 2D drawing, or maybe we're working with vendors that are supplying things in 2D. But also what I've seen in my experience is that for some industry standards, we're required for, say, new product qualification, our design review is going to take place. We have to share with them a 2D drawing. So in a way, to do business, our hands are tied to tick this box to get our product qualified. And by doing that, we have to have a 2D drawing. So there's requirements that aren't kind of by choice, that are still meaning in some industries you are required to be producing 2D drawings.
Yeah, and with that, I think we'll close our pure 2D design part. I will drop the recording to the previous session when we spoke about productivity in 2D design space. But obviously there is still space for 2D now. And let us know what you think through a Q&A panel. If you have strong opinion about that, or you want to talk about the things that how you use 2D design, please drop a note to us. It will be interesting to read it out and closer to the end of the session. And with that, Paul, but why don't you talk about your take on 2D plus 3D data reuse?
Sure. Okay, so we're going to be looking at reusing 2D data from AutoCAD to create 3D data inside Inventor. And we're also going to do it the other way. So we're going to talk about taking 3D data from Inventor and then reuse it as 2D data in AutoCAD. So I'm imagining if you're on the call today that perhaps you're transitioning from one product to another, like me. Perhaps you've been using AutoCAD and you want to move over to Inventor. Or perhaps you're just reusing or repurposing legacy work like John that's available in your company that you still need to use to create 3D details. Or perhaps you're collaborating with colleagues who can only provide you with 2D details and you need to convert them to 3D, perhaps a supplier. Or you work fully 3D inside Inventor, but your clients or customers are asking for 2D drawings as a deliverable. So I'm going to try and cover all of those scenarios. So let me just highlight some of these. So we're going to look at how to open Inventor drawings in AutoCAD, which might be simpler than you think. We're going to look at how to convert Inventor drawings to AutoCAD drawings to make sure if we want to have editable 2D line work. We're going to look at how to copy and paste from AutoCAD to Inventor. But I'm going to give you a tip around using AutoCAD blocks as Inventor sketch blocks as a way that might be slightly more robust. We're going to look at how to get an AutoCAD file into an Inventor sketch as a one-way reference, better as create an Inventor part file. But we'll also look at a slightly cleverer way to be able to link an AutoCAD file into Inventor using any CAD, so we can remain having a 2D file in AutoCAD and we can still do the updates in 3D. And then finally, I'm going to show you a little bit about factory design utilities, which kind of automates a lot of that process and builds it in for us so we don't need to be copying and pasting data backwards and forwards. Okay, so I'm going to just jump away from that slide and take us into Inventor. So this is the data set we're going to work with today. This is a high-speed switch. This is a switching mechanism from a ride like you might get at a fun park, that kind of thing, but it's pretty impressive. And we're going to take a look at this drawing that came with it. Okay, so the first thing we're going to do is we're simply going to close this drawing and open it up in AutoCAD. But before I do that, I want to talk to you a little bit about the drawings that we can create in Inventor. So I'm going to come up here to the Create New button, and I'm just going to mention that we have two different types of drawings in Inventor. We have the IDW and we have the DWG. I don't know how many of you are aware that there's two different drawing types. The IDW is native Inventor. So back in the day when we first created Inventor and we wanted to differentiate it from old AutoCAD, we created a brand new type of drawing. It's native to Inventor, it runs really fast, it's super efficient, and it's actually quite secure because there are very few drawing readers for it. But if you want to share files, you really want to be using DWG, and I'll show you why in a moment. DWG is a native AutoCAD format. You'll find it slightly bigger, and I'll explain why later, but it just means you can open it straight up in AutoCAD. So if I click cancel here, we can see this drawing file is a DWG file. And if I just close this down and hop us over into AutoCAD, I'm going to go over here to my start and open up this drawing. You can see it just opens up straight away in AutoCAD. So by using DWG file format, we can just jump backwards and forwards between the two. So what can we do with it now we're here? Well, you'll find that if you try and edit any of this geometry, I can double click into this viewport, it's not editable, and it's not editable because the model's in Inventor, right? So that makes sense, we can't do anything from here. But we could do some stuff like we could maybe apply a dimension, we could take maybe a revision cloud and revision something up, we could add notes, we can print from here. So for example, if you had people like maybe project managers at your company who didn't need access to the full Inventor model, but they did want to review your drawings, it could be a seat of AutoCAD LT is all they need to be able to open up a drawing file, add whatever comments, dimensions, notations they need, and then we'll be able to see that in a moment open up inside Inventor. Now, while we're here, let me give you a couple of tips. So I mentioned that although I can double click into this viewport, I can't actually edit anything. If I was to go to model space there's nothing there, right? There's nothing there because the drawing is inside Inventor. I can double click to zoom extents. There is nothing in here. But if I just wanted to grab one of those views, I can show you a quick tip. I'm going to use the AutoCAD insert command. And the insert command will pop up my dialog, which has disappeared. And that's the fun of doing live demo. Let me just try that again. Okay, I'm going to try and that's thrown me completely. So hang on, give me a second. I'm going to try and use the blocks palette instead. Okay, so give me a second to find that. I think I'm having some video issues here. So is there anything else I can do? I think I'm going to have to come back and show you that one. Okay, so the insert command would allow us to insert blocks, and we should find that all of these views are available within the AutoCAD command, within AutoCAD as blocks. So we can insert them in. Let me just try and take you to another drawing over here.
Yeah, it's difficulties of running a live session, right?
Yeah. And I think sometimes when you're using your video card to run the internet as well, it doesn't really help. So let me just restore this. So you can see in here one that I placed earlier. So what we could do, if we just wanted one view from our Inventor drawing to be able to put into an AutoCAD layout, we could take that one view, which I've got down here in blue, and we can pop it into a different drawing. Now, the difficulty here is that they're not associative. So although the DWG file is associative, as soon as we open it up, back up inside Inventor, it will update with whatever changes we made to the Inventor model, including any of those inserted blocks in model space. If we've copied and pasted out, it's not going to work. So perhaps you could start trying to mess around with X references to see if that would follow through. But I think if you really need these things to update between 2D and 3D, perhaps where you need to start using, looking at something like Factory. Okay, so that was unhelpful, but let me see if I can move on to the next one. Cool. Now, if we actually wanted to have editable geometry inside here, let me just close this drawing down. I'm going to go back to the sheet and save it. Close it down. We're going to jump back to Inventor and open it up. If we actually wanted to have two-dimensional editable geometry, then there's a different step we need to go to. So if I wanted to give this file to maybe a supplier, or if my customer is saying, well, I get the fact you can give me a DWG file, but I want something I can edit, mess around with, and include it in my own details, I would need to export this file to an AutoCAD file. Now, while I'm here, let me just show you that those dimensions and cloud that I added in AutoCAD are here in Inventor, so we're both working in the same file. To convert this to an AutoCAD file, it's just a file, save as, save copy as. And what we need to make sure we do is we need to make sure we switch here from an Inventor drawing file, which is what we have right now, an Inventor DWG, to an AutoCAD DWG. So I'll pick AutoCAD DWG, I'll give it a slightly different file name so I don't mess things up. And I'll click save. And then we can take a look at a moment in AutoCAD and see what we've got. So bear with me while it saves this one out. Cool, so I'm going to close this drawing in Inventor. I'm going to jump us back over to AutoCAD again. And inside AutoCAD, I'm going to go open this drawing up. So here's our AutoCAD version. And we can see what it's done here is it's actually kind of dumped everything out into model space. We've got everything now as two-dimensional 2D DWG geometry, so we can go through and edit this using our normal AutoCAD tools. There is some intelligence. You can see things like dimensions. It's understood that that's a dimension. It's put it through. Some of the decisions we could make, I just exported the whole thing, including the border, to model space. We can choose at what scale we want it to come through. So if you've got a drawing with multiple scales, you can choose which of those scales you want everything to come into AutoCAD at, whether it's 1:1 or whether it's the same scale the drawing was. Now I do have one other tip. We don't have to do this from Inventor, we can do this from AutoCAD. So let me jump in here and open up the Inventor drawing again. So this is, again, the Inventor drawing opened up in AutoCAD. If we wanted to do this from AutoCAD, there's a command here called Export Layout. So I'm going to choose here, Export Layout to Model. And again, I'm going to give this a name and click Save. So you might be able to do this as a batch process. If you've got a whole bunch of these things to do, you could write an AutoList routine, or maybe you can do it through the sheet set manager. And that might be a way of batch processing a whole bunch of drawings rather than having to export them one by one from Inventor. I guess in Inventor we'll do it with Task Scheduler. So whichever way you want to automate it, you've got some options there. Cool. So that's a couple of different ways to open Inventor drawings in AutoCAD. I think I'm good. There's one last thing I wanted to show you. Yeah, let's just show you how to, I'll close some of these drawings down. So what I did want to show you is one other way to reference Inventor drawings into AutoCAD. So is a little known set of tools here called the Layup Tools. I don't know if you guys have come across these. If you've used Inventor, these are going to look really familiar. But what we can do here is we can take a base view and we can grab a base view from an Inventor model. So if you've got people that are more familiar with AutoCAD that would like to be using AutoCAD, they're just doing the detailing, they're not doing the 3D modeling, so they're just producing drawing sheets. This could be one way you can use both products together. So I'm just going to take one of our models that we're going to be using later on, and you can see this looks pretty familiar, right? This looks like how we'd expect things to work in Inventor. We create a base view, we create some projected views. We can create section views from here and place those out on the sheet. We can create detail views. So I'll create a detail view from around this guy over here. And just like Inventor, if we move these things around, we do get the views updating as we move stuff. So you can see that my section view and my detail view both updated at the same time. So again, very familiar. If you're an Inventor user, this looks like something you'll be familiar with. The tool set probably isn't quite as developed as the Inventor tool set. There's probably fewer tools in here. But I just wanted to make sure you knew about this as one other option you could be using for working with the two different data types together. Great, so let's switch over now. I can get rid of both of these. We're done with those now. So now I'm going to talk about some different ways that we can take AutoCAD data and we can reuse that AutoCAD data inside Inventor. So I'm going to switch to Inventor and I'm just going to close down this large assembly because we're done with that. I'm going to switch into this part here. So I'm going to imagine that I'm currently working on this component and I've been modeling this up using some old AutoCAD drawings. But what I don't really want to do is have to have AutoCAD open on one screen so I can take dimensions and then be rebuilding it in Inventor on the other screen. Right? I want to reuse some of what I've got in AutoCAD over here. Now that's actually pretty straightforward. We can just do a copy and paste. So inside AutoCAD, I'm going to jump into the model. I'm going to zoom into this feature because I like the look of that. And I'm going to just filter out that dimension. And I'll right click and choose clipboard copy. So once I've copied this to my clipboard, I can then jump back into Inventor. And the key thing here is that because this is 2D data, I need to be inside a sketch to be able to paste this in. So I'm going to start a new sketch on this face and then just do a, let me just show that on the screen, right click and choose paste. And I can just paste this in straight into the Inventor sketch. Now, I kind of don't want you to do this because it can get a bit dangerous. When this geometry comes in, it's under constrained. You need to spend some time constraining this properly, and it can be just as time consuming as drawing it in the first place. So let me show you one other tip that I think might be more helpful. If you're going to bring stuff in like this from AutoCAD, how about doing it as a block? We have blocks in AutoCAD, and if you didn't know this, we have blocks in Inventor as well. So in AutoCAD, let's see if AutoCAD's going to play. Yeah, this time I've got this dialog just on the wrong screen. So I'm going to create a new block. I'll call this, let's say, ob round. Maybe I'll turn my caps lock off. And to create a block, we just need a few things. We need a base point, so I'll pick a base point here. We need some objects, so I'll pick some objects, again, apart from that dimension. And a title, that's really all we need. And a block is just a way of collecting this geometry together so it operates as one item. So I click OK. I've got one item now, which I can right click and choose clipboard copy again. And then I can jump back into an Inventor. And again, I have a sketch active. This is important, we have a sketch active here. And again, we can right click and choose paste. Now there's one extra thing, one extra step, which you might not have discovered. So this is the point I really want you to make a note of. Write this down or show it to somebody else, you don't forget. I'm going to right click and I'm going to choose paste options. This is the secret step. So when we choose paste options, we can say paste AutoCAD blocks to Inventor blocks. So I'll click that and choose OK. Now I'll left click to place this pasted block. And a couple of things happen. So at the top of the tree here, I get a new folder called blocks. If you are familiar with blocks in AutoCAD, you'll know that in AutoCAD we have a block is made of two components. There's the definition of the block and then there's an instance of the block. And if we change the definition, all instances everywhere will update. But in AutoCAD, we kind of never see the definition. We don't know where that's stored. We access it through an instance. But in Inventor, we get to see the definition. The definition is here in our blocks folder, and the instance is here in our sketch. And editing either of those will do the same thing. So if I wanted to place another version of this sketch block, I can right click here and choose place block. I could place another block over here. And the nice thing about this is because we've only got one block of geometry, we don't have to spend a whole bunch of time constraining this down. So let me see if I can get these constrained in quite quickly. I'll constrain these midpoints in together. I'll probably just need one horizontal constraint just to make sure that they don't rotate. And then something to give them a position. And here we are fully constrained. So rather than copying and pasting from AutoCAD and having all this unconstrained geometry that's going to mess up your sketches downstream, this is going to give us a much cleaner result quite quickly. Now let me just choose finish sketch here. I'm going to just put one more of these blocks on the end because I just want to demonstrate blocks to you because I think they're really useful. So let me place another guy down here. I'll rotate this one around. Give him a position because I can't sleep unless things are all fully constrained. I apologize if it's not super interesting to watch. Right, here we go. And then I'll turn these sketches into features so we can let me see if I can grab the whole lot. So we can see what happens. Now, the great thing about sketch blocks is that sketch blocks allow you to edit the sketch block and have the same geometry update in multiple places. So if you've not had a go at using sketch blocks, let me just flip this around and do a cut through all. And I'll apply that and do one more over here. So if you ever have geometry that exists in multiple sketches and you need to update them all at once, it can be a pain. Again, let me cut through all, that's pretty good. It can be a pain having to go in and edit them in multiple places. The nice thing about sketch blocks is that we can go in and edit the definition. So maybe I'm just going to grab this, as it's fully under constraint now, I'll just sort of drag it a little bit. Click finish edit block, and you can see it updated in everywhere we've used it. So I wanted to show you AutoCAD blocks to Inventor blocks, but I also just wanted to say, have you been using sketch blocks in Inventor? Because they're really useful, and I suggest you kind of take a look at those. Okay, so that's a couple of ways of just very quickly sort of down and dirty copy and pasting information into from AutoCAD into Inventor. How about if we just wanted to start with a blank sheet and use an AutoCAD drawing straight away? So let me show you how to do that. So I'll come up here and say, let's create a new part. Again, inside this part, we're going to need to start with a sketch. So I'll create a new sketch here. And the tool we're going to use is called Insert AutoCAD File. And this is going to be a one-way insert. So we come in here, we choose the AutoCAD file that we would like to insert in. I'm going to pick Open. And the dialog here is going to show us in a moment. Here we go. It's going to show us all the layers that exist in this file, so we can filter out layers that we don't need, that aren't going to come through into the drawing, aren't useful to us. And we also get a preview over here of what exactly what geometry we're going to be importing in. When we're done, if we click next, we can see we've got some options. We can change the units. We can do a little bit of constraining as it comes in. I'm just going to click finish. And this time the whole drawing is brought through into AutoCAD, into Inventor, as a sketch that we can now use to create some geometry. What's kind of nice about this is that, again, there's some intelligence. So the AutoCAD dimensions are turned into Inventor parameters. So if we wanted to make a change here, we can make a change and see that things do update. We can see that it's under constrained. So I would want to spend a bit of time constraining that and making it fully predictable. But if I wanted just to turn this into a model quickly for the purposes of this demonstration, let's come in here and start picking some profiles. Right click, choose continue, pick an axis, and we've got our part modeled up pretty quickly. So if you've got something that's in 2D, that's in AutoCAD, and now suddenly you need to start doing some stress analysis on it, or you just want to know how much it weighs, so you want to model it up and add a material, or if you want to better visualize it, produce a drawing, produce an illustration for marketing, any of these reasons why you might want to repurpose some of that legacy AutoCAD data and bring it into Inventor, that's a very quick way of doing it. It's a one-way ticket, so there is a slightly cleverer way which I'd like to show you. I'll start by opening up another part file. Now, oh, sorry, not a drawing, a part. So this time we're going to use something called AnyCAD, and we're going to use the import tool. We're going to use the import tool here from the 3D model create panel. You'll also see import over here in the file options, but I want to make sure that you're using this one here on the create panel. So we click import. I'm going to look out for the same drawing, this AutoCAD drawing. I'm going to pick here on open. Inventor will ask us on which plane would you like to place this drawing. So I'll give it a plane and give it an origin. And you can see it comes through in exactly the same way. What's different about this is we can now see this AutoCAD node in our browser. So this is a link to the AutoCAD file, kind of a reference, which is live. And in a moment, I'll show you what happens if I go back and edit the AutoCAD file and see what happens inside Inventor. But for the time being, I want to use this geometry to better do some work in Inventor. The one thing which you need to know is we can't reference this geometry directly. We do need to create a sketch first. So I'll click on my plane here. I'll click create sketch. And the tool we need to know about is called project geometry. But the version of project geometry we're going to use is hidden here under the drop down. We're going to use this one here called project DWG geometry. So I'll select this tool. I'll project in the outlines which are relevant to me for the purposes here. And I can click cancel when I'm done. Now I can choose finish sketch. I can choose my revolve command, pick all the different profiles, pick an axis again, and we're done. So it works in the same way. We get the same result. The difference is if I jump back into AutoCAD, and let me open up that drawing. So here we go. So this is the same drawing opened up in AutoCAD. And if I take this drawing, let's just do a stretch through here, maybe 25 millimeters. I'm going to hit save. It's really important that we save it. When we go back to Inventor, we can see Inventor has detected there's been a change. Local update flashing, local update button has the lightning flash above it, which tells us there's something that needs to be updated. When we click update, you can see that it responded to the update we did in AutoCAD. So this gives you another level of reusing your legacy data, in that you can maintain the AutoCAD model as the source of truth. You can maintain that on the system as a file that you want people to be able to use and update, but you can still turn that into a 3D model inside Inventor and get all those downstream benefits of having 3D, safe in the knowledge that an update in one place is going to update everywhere else. Okay, that's good. That's my whole lot. So I'm going to jump back now to PowerPoint. And the last thing I wanted to show you was factory. So if you don't know about factory design is part of the PDMC collection. So if you're a collection customer, if you've got AutoCAD and Inventor, you probably are a collection customer. So if you're not the contract administrator, chat to them, ask them about factory design utilities. It's a set of utilities that sit on top of AutoCAD, Inventor, Vault, Navisworks, and it also allows you access to things like Recap for point cloud scanning. But what it does is it connects all these different products together. So in this quick video here, I've shown you how you can insert an item from the library into AutoCAD. You can manipulate it, move it around. When you open it up inside Inventor, that 2D asset is twinned with a 3D asset, and the 3D asset is placed in. You can then do some work inside 3D inside Inventor. So you could be looking for clashes. You could be looking for connecting up to other equipment. You could be moving around inside Inventor. When you save and close, open up AutoCAD, the changes are updated inside AutoCAD as well. So if you really want to take advantage of having a 2D layout tool, perhaps even by a different member of staff, is doing layouts in 2D, but then at some point you want to take that 2D layout, bring it into Inventor and have it as a 3D model, then maybe factory design utilities is something you want to look at. Particularly, again, if you're a collection customer, it's already included in your collection. So if you haven't looked at it, you're kind of leaving it on the table. So I definitely think you should have a look at that. Did I forget anything? Is there anything I should show before I move on to the next section?
No, I think you covered everything, and I also posted the recordings of this presentation in high quality in the chat window. So if you want to go back to certain points, you can do that. Just save the links in the chat window.
Cool, so I can move on to the next topic then. So let me just make sure we've got the, yes, we're there. So we wanted to talk a little bit about data management. Again, for those of you who are moving from 2D to 3D, so if you're using AutoCAD and you want to move to Inventor, or if you're in the middle of making that transition, or if you have already moved to Inventor but you're finding the data model confusing, I wanted to give you a little bit of background as to what the differences are and how you might manage those. So AutoCAD and Inventor do manage their files differently. As you know, AutoCAD is a single document environment. So the model, whether it's a 2D or a 3D model inside AutoCAD, and all the drawings that go with it are usually contained in one file. If you're a really sophisticated user of AutoCAD, you might have been using X references, or you might use the sheet set manager, in which case the way Inventor manages its data might be more familiar with you. So Inventor combines many files into one design. So each part of your design is represented by one file. It's a separate model. And then the part models are combined into assembly models. And then assembly models, we usually create drawings from either the assembly model or the part models. So if you imagine you're in a factory, you're building pedal bikes, and there's a whole bunch of bins with components in. Inventor works in the same way. There's a whole bunch of components, and when you take the components from a pick list and you create an assembly out of those components. And so if in Inventor, if you change one of those components, it's going to change everywhere it's been referenced. Anywhere it's been used in the past, anywhere it's going to be used in the future. So if you're doing mechanical design, it's a way of managing part files separately to the drawings that they belong with. So it gives us a bunch of advantages. Now, to make sense of all this, Inventor uses something called a project file. And your project file can be found by going to the Get Started tab, clicking on the Launch panel, clicking on the Projects button, and you should see a whole bunch of projects appear there. There may be a number of them, just depends on what you've got set up in your system. The one that's current will have a little tick or a little check mark next to it. And a project file just tells Inventor where your files are going to be stored. So in the past, servers were big and they were slow, and if you stored a load of data on the server, then you'd want to Inventor looking over the entire server to try and find a file that it missed. So a project file is a great way of breaking the server up into smaller chunks. These days, very often companies will have like a mapped drive on the server for engineering data, so that only people that use CAD systems can reference that data. And you probably have one project file sitting on in that drive that manages everything. If you're using Vault, which is Autodesk's data management system that comes with the product design and manufacturing collection, then again, you'll probably be using one project file, and the project file just says everything's in Vault. So an Inventor project file has an IPJ file extension, and the folder that your project is in is known as your workspace. So the location of your project file tells Inventor where to look for your designs, your parts, assemblies, and your drawings. And Inventor will only look for files in the same folder as your Inventor project file or in a subfolder of that folder. So you'll notice that whenever you use Inventor's open command or save command, you'll automatically be taken to your workspace folder, the folder in which the project file is stored. So if you're having problems with Inventor resolving components, it's telling you it can't find things, you might want to check you've got the correct project file set. Now, you can't change project files when you've got a file open, so it can be a real pain. So you want to really make sure you've got the right project file set before you open up the first file of the day. So my tip is that when you first start Inventor, on the right-hand side here, you've got current projects, and the current project you have available has a green tick mark, again, a green check mark next to it. So just make sure that's the correct project file before you start work for the day. Typically, this would only change if you're saving that project file on the server, and at some point overnight your computer's lost access to the server. So maybe the server's been rebooted by IT, or there's been some network switch has gone off, but do make sure that's looking at the correct file before you start work. And you can make your project file current from this screen. You just hover over it. When you see the little tick mark pop up, click that, and you'll have the right project set. So Inventor allows us to combine many files into one design. So part files are referenced by assembly files. Assembly files can be referenced by presentation files. Presentations are where we do exploded views. And drawings can reference presentations, assemblies, or parts. So you can imagine an Inventor assembly as a container. It's just an empty file that contains a bunch of hyperlinks that says, hey, go out and look for this file, this part file on disk, and then bring the geometry in. So an assembly file might contain some information about where that part is in space, and it might have some information about the relationships between parts, but otherwise it's just referencing. So if we rename a part file, then Inventor's not going to be able to find it. Or if we have two part files with the same name on disk, then Inventor's going to get confused over which one it should use. So we want to make sure that we are naming parts uniquely. Now, if you're using Vault, again, this isn't such a problem. When you rename a file in Vault, Vault knows where it's been linked to, and so it can make sure it'll update all those hyperlinks to make sure they all point to the right place. But if you're using Inventor with Windows, this is a manual process. Windows will let you rename the file, and then Inventor won't know what to do. So it's quite important that you think about a file and folder naming strategy up front, and then you organize all your files as you create them. Now, when we talk about file naming, we've all got our favorite file naming scheme, so I'm not going to try and tell you how you should name your files. But if you're thinking about a file naming scheme right now, I thought I could maybe give you a few tips. So some things to consider. Drawings and assemblies tend to be unique to each project that you work on, or each product, depending on how you're focused. So you could probably contain your project number as a unique identifier, and the rest of the string could be the same as on other projects. Part files can be project specific. Sometimes it's a part you're only creating for that unique product that's not going to be used anywhere else. But part files can often be used between projects. So maybe part files need to have a unique naming scheme so you can use them in any project you like. Now, library components, a library in Inventor is something very specific. When we talk about a library in Inventor, what we mean is a read-only file location. So when you declare a folder as a library in Inventor, any file you put in that folder now can't be edited. So if you've got a very small team, it doesn't matter too much because you can talk to each other and figure out which files you should edit and which files you shouldn't. As the team gets bigger, maybe you need more ways of controlling, right? So you can put library files, maybe a supplier's component or something that you don't want people changing accidentally, into a library location, then it can't be edited. So these file names should definitely be unique because they're going to be used, they're designed to be used across multiple projects. And library files from your suppliers, maybe your supplier's already got a unique file naming scheme. Maybe you could just use their file naming scheme rather than having to rename everything you get from a supplier. One other thing you want to talk about is your output files. So your output files, let's say it's a drawing like a PDF or DWF or something like that. So they're not live data, they're a snapshot of data in time. So they could have things like the file revision or the date information in the file name, so you can distinguish which version of the drawing it was. But maybe also you want to have those files saved in a location. Remember we talked about earlier about having an engineering drive that's locked down so nobody else can get into it. So maybe your PDFs need to be saved in the general server, everybody else can see them, so that they find those files that they need. A few things to avoid. So Windows has a character limit of 252 characters. So keep your folder structure flat and keep your names short. I think for the geeks amongst you, it's actually slightly more, but you've got the C:\\/ you can't use, and then you've got a blank one at the end you can't use. So and avoid adding transient data that's going to change, like the reason for issue, its current state, its revision, because that guarantees you're going to have to rename the file, and that guarantees you're going to have problems with renamed files not finding themselves. You might also want to avoid things like metadata, like the description of the part, the vendor stock number, the material of the part, its appearance, because each of those things could change at some point in the future, and you don't want to have to change the file name to reflect that. But also, we'll talk a little bit more about that in a moment. All of those things can be extracted into a BOM anyway. And you probably also want to avoid things like calculated data, such as the dimensions of the part, its volume, its mass, things that are going to be subject to change in time. So we mentioned metadata. So when I say metadata, that's data about the data. So it's usually text-based data that's contained within the part file. So text-based data could be things like its material, its appearance, its description, its BOM structure. All of these things we can extract into the BOM, the bill of materials inside Inventor, and then we can use that to compile a parts list, or we can output it to an Excel file. So these are all things which I never consider a part to be complete until I've considered this metadata. Do I need to add it? Now, one tip here is you don't need to add all the metadata, right? So you don't need to fill out every one of these fields for every single component of your system, but you do need to be consistent. That's a conversation you need to have with your colleagues. Which information do we want to capture into our bill of materials, into our parts list? Maybe that's information you then want downstream into an ERP system or PLM system. So you do need to agree which ones are important, and you need to make sure they're filled out consistently, but they don't have to fill out the whole lot. Some of the metadata is generated automatically, so its dimensions, its mass and volume. Those are all things which Inventor calculates for you, and we can take those as outputs, and again, we can bring them into the bill of materials. So let's talk about file revisioning. Right, so with AutoCAD, file revisioning is pretty simple, right? Before you start doing any changes in AutoCAD drawing, you take a copy and you save it into an archive, and then you're done, right? You just carry on doing what you're doing, if you remember. But that's all we had to do with AutoCAD. It was only one file, it didn't matter. You can imagine with the Inventor, when we've got all these different files, all these different relationships, it can be very difficult to take a copy of everything. So one thing I'd recommend is that you consider your set of data you're currently working on as live, and so you never change the file name. Once you've created those components, you don't change the file name as you really have to, because it's going to cause you a headache unless you have Vault. So what I recommend is that instead of trying to create copies of these and saving back copies, that you use something called Pack and Go. So Pack and Go is a tool that we have that allows you just to take an assembly file or maybe a drawing, and it will zip up all the components that belong to those to that design, and it can create a zip file for you out somewhere on disk. So what that allows you to do is kind of archive the design in its current state, and then you have that audit trail that you can go back to and review later on should you need it. So a couple of tips there. One thing I'd say is make sure your archive location is not in the same place as your Inventor workspace, somewhere else, because you don't want two sets of files in the same location with the same name, because that will get confusing. So make sure you archive out to a separate drive or a separate machine. And if you ever need to use the archived version, make sure that you unzip it and then set Inventor to look at the project file that's contained in the archive before you open the files up. Otherwise, it's going to start referencing files from your current project file location, not from the archive file location. So there's a couple of tips there just to deal with archiving. So I think that's me just about done. I'll just mention at the end of this, I'm sure Anton can help us with some links here. So I've just given you a brief précis of 2D to 3D with AutoCAD and Inventor, and some tips on data reuse with AutoCAD and Inventor. Both of these are from longer webinars that we pre-recorded that are available to you on the Autodesk Knowledge Network. So if you want more information on any of those, then please feel free to check out those webinars and take a video. How are we doing?
Excellent. Thanks, Paul. That's I posted the links to the slides that you are previewing right now, and it's time to switch to John's presentation, and John will cover some of the e-learning content. So we built several courses where you can download the files, and use the courses to either upskill employees or maybe use it for onboarding of new staff members. So we'll talk about it in a second. Paul, thanks so much for the great presentation. Let's turn it over to John. John, you are the presenter right now. And while you're sharing, John, I want to bring everyone's attention that you're more than welcome to ask questions at any time. So if you have questions, just type them in the questions panel. You're more than welcome to do that. Thank you. John, it's all yours.
Oh, sorry. You can see my screen okay?
Yep.
Yes, we can. Yep.
Okay, great. Yeah, so kind of based off what was just described by Paul, we've also been working to create content to help AutoCAD users with kind of existing 2D data, how to bring it into 3D and start to build 3D models using Inventor. So the idea of this part of the presentation is just to take you through a quick preview of the content that's been created. So I'm going to run quite quickly through this just to keep us on track for the top of the hour. And so the first section of the content is looking at the benefits of 3D modeling for mechanical engineers. And the course starts to look at some of the changes that we can see in our industry for how products are designed. So some examples that are included here are just the greater focus on collaboration, as kind of we get better tools for collaborating with customers, with internal design teams, and how that is a requirement for greater clarity of content so that your design reviews can happen more effortlessly. And then also just touches on how we can see computer-aided workflows like simulation and CAM becoming more commonplace in our industry. And then looking at how 3D modeling can help to complement these changes. I don't want to go through all this in such detail because that's what the content is for, but this next part will just kind of touch on how 3D modeling can help aid you when you want to tackle these changes in our industry. In a similar way, the content reviews changes for how parts are being manufactured. So again, it kind of touches to the first point, but we can see kind of CNC machining practices becoming a lot more commonplace. And also as the technology gets better, advanced manufacturing methods like additive manufacturing are also become more prominent. And with these advanced manufacturing workflows, if we're modeling our designs in 2D, there's going to be some remodeling required in most cases to take them to the shop floor. So this introduces the risk of human error and also increases our time required for manufacturing. And like before, the next section kind of looks at how 3D modeling can help complement these changes for manufacturers. But again, I won't go into too much detail. I'll keep us on time. The content also just takes a quick look for what is Inventor. For people who aren't familiar, goes through some of its most basic features and then starts to look further down the line at what technologies begin to come available to you as you start your 3D modeling journey. One thing as part of the content, we supply you with a data set to play with. So it's a practical course that you can follow and really follow exactly what you're seeing on screen. So it's a simple data set that we provide you with. It's this collar flange assembly drawing, and it's made up of 4 machined parts and then some bolting for connections. And we really focus on these 2 machine drawings. So this collar insert drawing and then the collar end cap drawing. So quite simple drawings, and we'll be applying workflows to recreate these in Inventor so that eventually we can end up with something that looks like this. So this is the same collar flange assembly, but now remodeled in 3D. Again, we can see our collar end cap drawing and collar insert now remodeled using these workflows that are demonstrated throughout the content. So something that you'll see in the content popping up a lot are these flashcards. So this roughly follows the kind of workflows that Paul's already demonstrated, and I've isolated it into 3 workflows. So the first being the simple copy and paste of geometry from a DWG into a model sketch, and also looking at how we can utilize existing AutoCAD blocks and convert them to Inventor blocks. Each of the flashcards includes a brief description of the workflow, some key notes about what it does and doesn't do, and screen captures from Inventor, like that magic trick that you have to remember to select your paste options. So these are kind of the flashcards that you can use to refer back to when you're actually applying the workflows. Also workflow 2, which Paul already demonstrated, which was inserting the DWG into a model sketch. We see the same layout, a description of the workflow, keynotes, and key screen captures. And the third workflow, which was to import the drawing itself into the part file. And again, description and keynotes. So when you're following the workflow tutorials, and as Anton mentioned, these can be for you as someone who wants to learn how to take 2D data into 3D, or as a training resource for onboarding new employees. What you'll first learn is how to identify suitable 2D data for these workflows, and also some best practices for preparing the data. So a lot of the workflows can be made easier to apply, I would say, by using layers and things like that. So there's some tips that we can give you for helping how you use these workflows. So that's best practices. Also, we'll include a step-by-step walkthrough of each of the workflows. So I've listed the 3 separate workflows here. And along the way, we'll be providing recommendations to help you select the most appropriate workflow for what you're trying to achieve or what your project deliverable is. Again, for people who aren't very familiar with Inventor, the content also looks at, now that you have your 3D models after applying our workflows, it's what do you do next? So some basic functionalities in Inventor. So reproducing the 2D machine drawings of the collar insert and the collar end cap, how to create an assembly model, how to reproduce that assembly drawing that we looked at first, reproducing that in Inventor. And then, like Paul already mentioned, some of the different methods for linking the 2D Inventor data back into AutoCAD. And there'll be kind of practical videos that you'll be able to follow along with using the data set throughout. And then the last thing that's contained in the content, and again, kind of following what Paul's already presented, are these data management considerations. So looking for people who are not very familiar with Inventor, we'll give an overview of the different Inventor file types, so part files, assemblies, the 2 different drawing types, project files and template files, and then also introduce you to the library files, content center, all this exciting stuff that you have in Inventor. And what's an important topic when you're applying these workflows is revision management and how you're going to manage your new 3D data that's made in Inventor, the 2D drawings that you create in Inventor. If you're applying a workflow that keeps the original drawing data, the source of truth, as Paul called it, in AutoCAD, how to manage all these different files once you start to work in 3D. So that was a very quick introduction to what I had to present, but that's all. I hope this was informative, Anton.
Yeah, and John, thank you so much for the overview. And you will receive the link to this e-learning course. It's going to be a free learning course created by John. You will be able to take it or share it with your coworkers so that they can use it for onboarding or maybe as upskilling courses. So feel free to use it. It was created for your benefit. It's time to wrap up. We're at the top of the hour. We covered most of the topics, but if you have any questions or comments or about the 2D to 3D workflows or 3D data annotation in 2D space, please let us know. We're around and we'll be happy to address any questions that you have. And while you're thinking or typing your questions, I actually have one quick question to you. So we are hosting these virtual meetups every second Thursday of each month, and we have some topics lined up. But I'm wondering, like, what would you like to hear next? So, what's your opinion? What's on your mind? And I started the quick poll. If you could click, what kind of topic is the most interesting for you? Let us know. It's right up on the screen, and I'll keep it open for 5 more seconds. Excellent. So let me close the poll. Thank you so much for your votes. And it looks like our leader is tips and tricks on productivity. That's exactly one of it's the next session. In fact, well, we talk about design accelerators and all kinds of productivity tools in Inventor. But other topics that you click here, they're also coming. I will just use your votes to reprioritize them. Right. Excellent. Let me quickly check if there are any questions. And we have a couple of comments about how amazing the description of blocks was and how informative it was. Thank you so much for the comment. But we don't have any questions yet. With that, I guess we will close the session, and I wanted to thank everybody for joining our virtual meetup, and also don't miss a chance to register to the next one. So let me send you the link with the registration to the next session. So it's in the chat window right now. So please register to the next one, and we'll see you again next month in January. Paul, John, thank you so much for great presentations, and you'll receive the audience. You will receive the recording of this session as well as the link to the new course in the follow-up email. And we've got a comment that it's the best community seminar so far. Thank you so much for the feedback. And I have a great rest of your day, everybody, and thank you so much for joining. I close this session. Yeah.
Thank you.